I'm going to go ahead and introduce our next speaker and say just one word about the purpose of this portion of the workshop. We wanted to try to give as many opportunities as possible to see math circles or math circle ideas or from as many people as possible, and this seemed like a nice way to make that happen. One of the things that I was really lucky to experience as the former organizer of the Stanford Math Circle was I got to see a lot of different of speakers come through and give circles, and I had the pleasure of sitting in the audience and being part of the circle. It was actually one of my favorite parts of organizing the circle, and it's an experience that most of us rarely get. So that's the intent of a lot of this workshop, is to be able to participate and sit in on some circles, or at least get some neat ideas. And our next speaker, Reiter, is full of these sorts of playful ideas, full of great problems. Thank you. I did mean to do that, actually. I'm Sam Vandervelde, one of the three individuals who's helping to organize this workshop this weekend. Thank you. Yes, along with Kathy O'Hara and Matt Beck and Amanda Cernevi. So let me deflect attention from myself as quickly as possible to Harold, who's actually been doing this for a long time. He began the Charlotte Math Club in 1987, and that sort of evolved into a math circle of sorts. Do you call it a math circle now?
We call it a club.
There's still a math
teacher circle.
Club. And then on top of that, he's been very much involved in the teacher circle in the area, and so we're delighted that he could be here today.
Thank you, Sam. Thank you, Sam. Is the speaker working? Can you hear me all right? I'm supposed to use the 3-foot rule, and that is I mustn't speak any louder than if I were speaking to someone just 3 feet away. I have a vocal cord problem. I want to tell you first that I am delighted to be here among old friends and I think lots of new friends. This is my first trip to MSRI, and so far it's just been delightful. Before I tell you about the problem I want to really talk about, I want to solicit your help. This is a problem that was posed to me just before the Super Bowl. I have a friend who works at NCTM who put out this matrix of digit values and cost. The idea is that if you want to get in this game, you buy squares, and each square is a pair of digits, one for the Cardinals and one for the Steelers. The entire pot is split up into 4 parts, one for the first quarter, second quarter, third quarter, and the final score. And if you happen to own, for example, this square right, let's say here, you've paid 70 cents. And if the final score is Steelers 24, Cardinals 13, then you get a share of the pot. Now, I was wiped out by this game. I entered and I didn't win anything, even though I spent $10 on a lot of cheap squares. And I am determined to do much better next year. He's going to do this again. I've offered this project to some seniors at my school as a senior project. I want them to analyze this matrix and tell me what I should have done. I have some ideas, but I would love to discuss this over dinner. If anyone has some ideas about how to take advantage of these numbers, I know that there's some good ways to deal with this mathematically. The other thing I want to mention before moving on to my problem is Kin. Some of you may know about Kin. It's the new Sudoku, and I think it's great for children. I think it's good for adults. I love Kin. I like the 6x6 especially, although at the Kin website you can find as big as 9x9. 9x9 let me just tell you a little bit about what it is. In this 4x4, you are told this 8x. What this 8x means is that the three numbers that you put in the three boxes, here, here, and here, must have a product of 8. This 1 minus means that these two numbers differ by 1. And you're filling up the 4x4 grid with 1s, 2s, 3s, and 4s so that you get the Sudoku kind of arrangement with ones, with one of each item in each row in each column. And there's a typical 8x8. This turns out to be somewhat of a project. It's not just an exercise. You can't do it in your head very well. You have to have paper and pencil, and that's fine. You can. It works to do it with paper and pencil, but it's not as much fun. The 6x6 is just right. It requires some real mental arithmetic if you don't write stuff down, and some of the same logic that you use in Sudoku. I urge you to look into this. There are 2 websites that have this. The New York Times has its Kin, 6 different problems every day, and the Kin itself, which the New York Times uses, the website for Kin itself has about 6 or 7 different size problems. The 7, 8, 9 problems are pretty challenging. The problem that I really want to talk about today is, for me, more than 20 years old. It started for me as a request from Stephen Maurer. Steve was the, some of you may be familiar with the book that Stephen and Anthony Ralston wrote on discrete algorithms in discrete mathematics. Steve was the chairman of the American High School math exam back in the 80s and asked members of the committee and panelists to put forward some problems that used algorithms. And in an attempt to do that, I worked, this wasn't new at the time, but I decided to try to pose a problem on this so-called crawl, where a bug starts at 0, 0, and it crawls 1 unit upwards and to the right, then down, producing successively larger squares. It goes through its crawl entirely in the first quadrant, and then you can ask questions like, where is the bug after 1994 minutes? And I think maybe our problem was, where is the bug after, it was the 1989 problem, so what is the ordered pair where the bug is after 1989 minutes? I forgot about the problem at that point, and it was only about I guess maybe it was just 4 or 5 years later when I was asked to help coach the state math counts team. This was along about the time that Lenny Ng was coming along. Some of you may remember him. He scored a perfect score on the ASME 4 consecutive years and perfect Amy's 2 or 3 consecutive times, won some gold medals. He's now a professor at Duke. Lenny was 10 years old, and by the time he was 12, I couldn't help him, but at 10, I could help him a lot. And so I gave Lenny a problem very much like this. I'll show you the problem that I actually gave him. I changed the problem a little bit so that now the bug is crawling around the plane in such a way that it fills up it fills the lattice points of the plane. It starts at the origin and moves one unit. Can everybody see that all right? I have a bigger version. Oh, you have it. Okay, great. So here's what happens. The bug starts at the origin. It crawls 1 unit in the first minute, turns left, 1 unit in the next minute, turns left, crawls 2 units, turns left, and it keeps crawling in such a way that it fills out these squares. Okay, so at time 3, it's filled out a 1 by 1 square, and then at time 8, it's filled out a 2 by 2 square. It's not a 9 because we started at 0, you see, and when the bug gets right around to this point, this will be 15, and this will be 16 minutes. I told a colleague that I was going this weekend to the Great Circles Conference. He said, "What are you going to talk about?" And I said, "Squares." So once again, the idea here is where is the bug after 2009 minutes? And it's interesting that I've given this problem now to various groups. I worked in a program last summer, a program for middle school and high school students in Southern California, and they ate it up. They got it right away. I've given this problem to middle school teachers, and they really struggle with it. And I've also given it to a couple of my university seniors, and they have more trouble with it than the middle school teachers do. I don't try to push them in the right direction. I want them to digest the problem and work it essentially from scratch. I'll talk with them about it, but I don't give them ideas. So for several venues and in different settings, I used this problem until about 3 or 4 years ago, when my friend Arthur Holzhauser, with whom I do some work, and I were asked to put together the Michigan Math Challenge. It's a competition for college students, math majors, from a dozen or so, maybe 20. Actually, I guess there were 40 or 50 teams involved. A Saturday morning, 3-hour challenge. And we decided to look carefully at this problem and see what we could come up with, some more sidelights to this problem. And we came up with a few ideas that I think you may find interesting. You can ask either, where is the bug after a certain time, or at what time does the bug get to the ordered pair 19,99? And then we looked at it a little further, and we came up with some other problems, like suppose 2 bugs leave 23 minutes apart. Is it possible that they will ever be exactly 17 units distant from one another? They're 23 minutes, so one leaves and the other leaves 23 minutes later, then can they ever be exactly 17 units apart? And the middle school kids do great with this. They've just learned the Pythagorean identity, and they start playing around, and they know that you have to get to a corner, and so you have to have a right triangle somewhere with the legs summing to 23 and the hypotenuse of 17, and they get it. And the middle school teachers struggle with it. And the college students don't get it at all. Now, ultimately, you would like your students to be able to write down the function that takes the number of minutes and produces the location. You can also ask for the inverse function. Find a function from the integer lattice points into the positive integers that describes when the bug gets to that lattice point. Another interesting question is, suppose that the bugs leave, one leaves at a certain time, the next one leaves 100 minutes later. Then how close can they get? Or suppose the distance between the times difference in times is 101, then how close can they get? And so it's interesting that you get a very nice answer different in those two cases. It was only after a good deal of investigation into this problem and a few like it that we realized that you can put these problems in a nice category which I call crawls. A crawl in the plane is a bug that leaves the origin at time 0 and every minute goes to a new lattice point. The crawl has to be a one-to-one correspondence between non-negative integers and lattice points in the plane, and the bug must never take a step that's bigger than the square root of 2. It can only go to a lattice point that it can see right nearby. And so you can make up lots of problems for yourself. You can develop your own crawl. And let's see, I think I have a couple of examples here. Yeah, here's one. And in this problem, the triangular numbers come up as opposed to the squares. And I think you all have this problem. And here's yet another one where the algorithm depends on the location of the bug. It's at a certain point, and it knows where it is, and if its location satisfies a certain inequality, then it moves one way. If it satisfies another inequality, it moves another way. And you can ask some of the same questions about this crawl that you ask about the others. So if anyone is inspired to come up with some new crawls, I'd be glad to add your crawl to my list, and I'll give you some crawls of mine. I think I'm done. Thank you.
So hopefully this has generated lots of ideas and will spark lots of conversations too over lunch. Now that you know Harold, over lunch and tea and so on. But we're going to move right to our next speaker.
I'll pass this on. My name is Matt Beck. I'm one of the organizers, and it's my pleasure to introduce Anna Burago. And Anna has degrees from St. Petersburg and the University of Washington, So you can guess at what age she got introduced to math circles. She's one of the main organizers of the Northwest Academy of Sciences in Seattle, which has been running for something like 7 years. So, yeah. So, please. And I'll hand this here. Hand this over to you.
Sorry, can't find my memory stick. Oh, it's there. Wait, PowerPoint presentation that. Yeah.
What would you like to use to open it?
Probably you have the older version.
Which program?
PowerPoint presentation.
Let's see. Yeah, from the list. Try that from the list.
No, maybe I have new version and maybe an older version is installed here.
It could be.
Yes, because you have Microsoft PowerPoint here, but. Yeah, okay, we'll figure it out.
Okay, would you like to use the board instead?
I can use a projector as well.
Overhead projector?
Yes, like the one that can project my papers on the board.
Transparency
Yes,
or paper?
paper.
Oh.
Yeah, sorry, it looks like I have my PowerPoint presentation in new format that's not installed on this computer. Okay, thanks. So, my name is Burago. I am from Seattle, and we have been running two math circles in Seattle for the past 7 years. We started one 7 years ago. We started another one for the next group of kids who grew up to the proper age 4 years ago. Is it better?
Move the microphone higher up.
Okay, sorry, like I have not too much experience public speaking, so probably you should assist me. Is it better this way? Okay, so first I should apologize. I prepared a handout for this presentation, and I wanted everybody to have this handout, but I thought the default behavior would be to print out the handout for everybody. I never explicitly asked for it. So I think, yeah, so now you don't have it. I think the good way to solve this problem, I'm going to place the handout to my website, and I'll give you the link, and later you can use it.
It is on the website for this workshop.
No, I never asked, like, yeah, the question is what is default? Okay, so today on this great math circle presentation, I was going to talk about math competitions and math contests. Why? Because they really make a great math circle class session. In our math circle, we usually practice math competitions. We do math battle, we do math auction, we do math hockey, and we even invented a few competitions of our own. Our most popular ones are mathematical battle and mathematical auction. And since there is a good presentation on mathematical battle today in a few hours, I decided I'm going to talk about mathematical auction. Okay, so first, why mathematical contests are good? First reason is students really love them, because they love to compete. They get really engaged. Second, they're very educational, because students learn to present their solutions and learn to analyze the solutions of their peers. Third, mathematical contests are a teamwork activity. Students get together, basically make friendly relationships. That's one of the goals of a math circle. Fourth, it's very hard to spoil a mathematical contest. Basically, if the problems are good, then the session is always going to be good. It's guaranteed. Now, what's special about math auction? Math auction is one of the most engaging mathematical contests. Its rules are very easy to grasp. That's definitely a plus. Then, it uses special type of problems. These are not the problems that require proof. These are more open-ended constructive problems with a partial solution that's easy to come by and with possible improvements to this solution. Since these problems don't require strict mathematical proofs, then even the students who are new to math circle and younger students and not prepared students can participate in math auctions and still have a great math circle session. Now, the rules. So you can play math auction individually or in teams. You can have 2 teams or more than 2 teams. Usually in our circle we have 2 teams. Each team is handled a set of problems and allocated time to solve these problems. Every problem has a total value in some fictional currency assigned to it. And every team gets some certain amount of this fictional currency. It could be 2 Greeks, dollars, cent dollars, moon dollars, little elephants, whatever it is. Then teams spend some time solving these problems. When actual auction starts, problems are put up for auctioning by a teacher one by one. So suppose problem 1 is placed on an auction. Teams are placing bids in order to buy a right to present a solution to these problems. A team that places winning bid presents its solution. But what is the trick? The trick is that problems are constructive. So even a team has presented its solution, probably some other team has a better solution to it. So if some other team claims that it has a better, stronger solution, a problem is put up on auction again. So teams are bidding one more time. Winning team presents its solution. And this process goes on till no team believes that it has a better solution. Finally, a team that actually presented the strongest solution wins the total value of the problem, or the other teams are losing their money. And it goes on till all problems are auctioned. It's a very exciting game, because tactical moment is very important. It's also money, excitement, auctioning, bids. Kids really love them. In these types of problems, constructive problems, it's very important, both for a teacher and for students, to clearly understand what a stronger, better solution means. And it differs from problem to problem. And it's easier to explain it on example. Here I have examples of 3 different types of... How can I do it?
Is there a URL for the... It was mentioned that it was available online.
Online on MSRI site.
Supposed to be on the site for this conference. Kathy just stepped up. She might actually make copies for everyone. That might be the reason why she stepped up.
Oh, We can try to pull it up on this computer. Mm-hmm. Uh-huh. Anyway, I was going to read all these problems, so I think it's all right that you cannot read them. Because I was going to read them and I was going to talk about them. Ah, okay, excellent. Okay, so problem number 1. Cut a circle, not inter, but with 7 straight lines, in such a way as to get as many triangles as possible. So for this problem, it's pretty straightforward what a stronger solution means. Stronger solution means to cut a circle into more triangles than the previous team did. So for example, one team, so suppose this problem is valued on 102 Greeks. One team bought it for 15 Greeks and presented its solution. And its solution was so how many lines do I have here? 1, 2, 3, 4, 5, 6, 7. And how many triangles do I have? 1, 2, 3, 4, 5, 6, 8. So this team presents its solution with 8 triangles, maybe more. Okay, what? No, triangles are real triangles with straight lines. No, only small. Again, it's up to a teacher, basically. You formulate the problem, and you choose the way it should be interpreted. Just you should know how it's interpreted, and kids should interpret it the same way. So usually kids ask questions while they're solving the problems, and you answer these questions. So we told them that, no, we count only smaller triangles. So a team bought this problem for 15 Greeks, presented solution with 8 triangles. And another thing about math contest, that it's even while the contest bidding itself happens, kids are actively engaged in creating new solutions. Because very often a winning solution would combine ideas of their solution and solutions that just has been presented. So kids are running there, like trying hard to create something new. So somebody noticed that this solution could be modified, that one of the straight lines can be shifted in order to generate more triangles. So when the solution is presented, new round of bidding happens. Next team buys it, for example, for 5 Greeks and present a better solution with straight lines here. So now I am supposed to get 5, 6, 7, 8, 9, and so on and so on. Till finally, like, bidding on this problem is over. So winning team collects the money, losing teams lose their bids. Second type of problem, find as many solutions as possible to the following alphanumeric puzzle. Bag plus ball equals scam. For this problem, it's a winning team is a team that presented a solution that has not been presented before. So it might happen that one team found 4 solutions to this puzzle. It bought the right to present a problem, presented their 4th solution. And second team found just 1 solution, but it was not there. So now they're bidding on this problem, they're buying it, they're presenting their one solution, they're done, they're collecting the money. So tactics is very interesting. It's important there. And again, kids love it. Third type of problem, using just the digits 1, 2, 3, 4, 5, 6, and 4 arithmetic operations, write as many consecutive natural numbers as possible starting with 1. Example, and by the way, I have a typo here. It should be 2 equals to 1, 2 plus 3, minus 4, minus 5, plus 6. All numbers should participate.
Must they be in order?
Yes, they must be in order. And again, it's up to you to choose the rules, but for this problem, if you tell them they can be out of order, then it's too easy. Yeah. So, again, for this problem, a winning team, if a team places another bid on a problem, it's supposed to pick up from the number that the previous team basically dropped off. So if one team presented 4 solutions, like 1 equal 1 minus 2 minus 3 plus 4 minus 5 plus 6, 2 is 1, 2 plus 3 minus 4 minus 5 plus 6, 3 is like minus 1 plus 2 minus 3 plus 4 minus 5 plus 6. 4 equal to 1 times 2 minus 3 plus 4 minus 5 plus 6, and got stuck there. Then a team would have that would have a presentation for 5 would be a winning team. Or maybe a team that would have a representation for 6 would be a winning team. So again, strategy, strategy, strategy. So these base auction problems, again, you can vary the level of the complexity of problems. Like these problems are very good for younger kids, like 5th grade, 6th grade, 7th grade, 8th grade, everything goes. You might have much more complicated problems that are better for older kids. I have here in my handout full example of mathematical auction with problems that are much more interesting. Like, for example, number 3. Group of planes is based on a small island. For every plane, its tank has a capacity for enough fuel to fly halfway around the Earth. The goal is to use as little fuel as possible to fly one plane around the Earth under the conditions that plane can refuel one another while in the air, and under the conditions that all planes should finally get to the base. It's a very interesting open-ended research problem that basically gets kids thinking. Okay, then resources. Well, how to find the rules of mathematical competitions, where to get problems. The best book I know, Mathematical Circle Russian Experience, have special section on mathematical competitions. It has rules. It has sets of problems. Then, on the website of our math circle, we try to keep we have special section on math competitions. Again, we have rules. We have sets of problems. And we hope to add more problems as time goes on and we have time for it.
You certainly don't have to kill yourself writing all these down. So we'll make sure you get these in some form. So don't break your fingers.
Mm-hmm. Okay, thank you for attention.
Thank you.
Next, we'll have Mary OKeeffe. I haven't had a chance to meet Mary in person yet, but I'm very excited because Mary is the leader of the Albany area math circles, and earlier in the day, someone was asking about what to do when you have a wide range of ages and ability levels. for how she deals with this in her circles. So thank you very much, Mary. Okay, so can everyone hear me? Okay, so first of all, it's an amazing honor to be here. I feel like somewhat of a fraud because I'm not a mathematician. And years ago, when I started the Albany Area Math Circle, my daughter Allison Miller said, "That's a very pretentious name. We shouldn't call ourselves a math circle." So I was very grateful to Mark Saul for his saying this very inclusive definition of math circles. So I'd like to motivate this by showing you a few pictures and asking you what's wrong. These are the pictures that appeared last October in the New York Times. And that one on the left, I guess it depends on your left or left, is my daughter, Allison Miller. And so they're three girls that are like supposed to be good at math, and they all look really unhappy. And they're all very isolated. I mean, actually, the picture with Allison actually has like a little piece of somebody else, but there were actually a bunch of other people that got cropped out of it. Nobody looks very happy, and it really connects with what Mark was saying earlier about the pictures of mathematicians as being really isolated and unhappy people. So what's missing, and which is what I tried out of desperation to create, is a community, a sense of belonging, camaraderie, joy, shared eureka experiences with kindred spirits, and laughter. And I know all of those young women actually have all of those things in their lives. I'm sorry that the New York Times chose those particular pictures because it does paint a misleading picture, and I've tried to address that on the website for our math circle by having more engaging pictures showing the community. There was actually a workshop here last fall, I understand, about how to make graduate school a more positive experience for young women. And there was actually a woman at SUNY Albany, not very far from where I am, Abby Herzog, who talked about this notion of developing a mathematical identity or sense of belonging. And that's what motivated me, an unqualified economist, to start the Albany Area Math Circle. When my daughter was 8, we were in a very good school district. Their solution to their having noticed that she was ready for more advanced math was to send her down the hall to a supply closet by herself with a computer. And if the rest of the 3rd grade was working on 2-digit addition with regrouping, then she on the computer got to work by herself in the supply closet on 3-digit regrouping with addition. And this is a very good school district. It's the site of the GE Research Labs, which has produced 2 Nobel laureates. I said there had to be a better way. It's interesting what Mark said about Christmas of 3rd grade. Well, Christmas of 3rd grade was the end of her career in school. And after that, we pulled her out and homeschooled her. But again, I didn't want her to do it alone. So we started volunteering in actually inner city schools. And I said to the teachers, just give me your troublemakers, like 5 or 6. And Allison and I will come in and we'll do math games with them. And eventually, this grew over time into something that became the Albany Area Math Circle. I'll just do a few fun things that we did that are quick. I would bring in a pan of brownies, and I'd say, how can we make these brownies last forever? And before cutting them, I would hand out squares of graph paper with 64 squares,
and markers, and they would say, suppose we eat half of them the first day, and a quarter the next day, and an eighth the next day, and a 16th the next day. And they would color them in, and they would see they'd last forever. Then we'd eat the brownies. And I had more games like that. But I also was very encouraged to hear Harold say that, he could do things for Lenny when he was 10, but when he was 12, it was beyond him. And the same thing was true for me with my daughter, Allison, and some of the other people who ultimately joined the math circle. So I had to find ways as she got older and her friends got older to engage them. This, by the way, this is the image of mathematicians. This is a bunch of, we have an annual picnic for our Albany area math circle students. And so I have lots of happy images on our website. And I do think that girls are very well represented in our math circle. And I have more stories. One of the stories, these are 3 of our original math circle members. And they've now all graduated from college, but they still, when they are home on vacation, they still come back and solve problems with the students, which I think is like the ultimate measure of success, is that these students they're not eligible for math contests anymore, but they just love the community and the fun of coming back and solving problems. And again, just more smiles. We do have mathematical competitions as one aspect that the Math Circle does, but I consider it the frosting on the cake. And I really am trying to reach a much broader and more inclusive audience. And so I created these awards, the heart and soul of Math Circle award winners. I really try and create a sense of ownership of all the accomplishments of Math Circle by encouraging students to help younger students, to help perhaps more advanced students by asking good questions, by pushing them harder to think more deeply about what they're doing. I think that one aspect of the question that was raised earlier this morning about the girls and the boys not being happy being in the same room. We have a big room that we work in. Our high school students it's a room for 60 students. We typically have about 30. And students are working in flexible groups among themselves. For the first hour and 15 minutes, they are working by themselves. I hand out problems, a wide variety of problems when they come in the door. And they sit down and they're working for 75 minutes individually on their own. People say, well, gee, this is stupid. They could be doing this at home. The fact is that they have very crowded lives. If I assigned it as homework, people wouldn't show up. And the other thing is that nobody knows what everybody else is doing during those 75 minutes. Everybody is sort of in their own separate sphere. There are too many problems for any one person to do them all. So everyone is choosing the problems that feel accessible to them or might be accessible to them. Then we have pizza, which is very important. And then the students assemble into groups to talk over problems. And they choose those groups themselves. But an important part of my role is cross-fertilizing the groups, connecting them, looking at who is disconnected, who is feeling left out, trying to find a role for that person that's empowering for that person. And we have a continuous stream of new students coming in. And one of the things that I found to be the most effective is to take that student, that veteran who might look a little disengaged, a little lost, like, oh, everybody's better at this than I am, which may or may not be true, but they're feeling that anyway, and put them together with a brand new student who's feeling lost, and suddenly they become the expert. And that's very empowering. That's, I think, that is one of the things that has made our Math Circle so successful. It is an incredibly diverse group. We have anybody in high school who wants to come can come. We have this year, we have about 30 students who come regularly. 5 of them qualify for the USA Math Olympiad. We have other students who aren't even interested in math competitions, which is perfectly fine. We have other students who try them and who haven't made the AMY yet, and that's fine too. And we have a community where they all feel a sense of ownership. They all feel a sense of identification and belonging. And I think that a lot of that is because of the way I've structured things. If you go to our Hall of Fame, you notice that the first thing I list are the captains, who are not always the most mathematically able, but they're the ones who inspire and help and encourage. Then I have our Heart and Soul award winners, who are 2 co-captains, who are wonderful, who retired a few years ago, who never made the USMO themselves, but who incredibly encouraged other students and who I consider probably proximate causes of several of this year's USMO winners. Then I list all of the students who have helped younger students. And this, again, I think is the answer to those 3rd grade boys and girls. You get some high school students in, some charismatic, both male and female students, and you break them up into groups. You have a big room where they can spread out, and you, as Mark said, you read the students. You look at that chemistry and who works with who. So maybe because I'm not so good at the math, I am good at kind of looking at what works with what. And then, underneath all of this, you eventually get, do you see this long list of all our students who've worked with younger students? Then, you get to our USMO qualifiers and our AMC perfect scores and, so it sends a message. It sends a message about belonging. That you belong not just because you made the USMO, not just because you helped us, with a whole lot of points on the New York State Math League, but you belong because you ask questions, because you're brave enough to ask questions, because you're willing to make mistakes. And in fact, if you go to the front page of our website, which I hope I can, actually, yes, the home. You'll see what is Albany Area Math Circle, and it is the key thing is you need to come with an enthusiasm for making mistakes. And I tell a lot of stories about making mistakes. I love Feynman talks about making mistakes, and Einstein talks about needing a big trash can for his office at Princeton. And I talk about Andrew Wiles working for all those years and then discovering a mistake. And the other thing is that I have our strongest students, the ones who qualified for the USMO or whatever, they get to see, even the rookies and the new students, they get to see that everybody makes mistakes. And I especially get them to see that the grown-ups advising this math circle, I talk a lot about the mistakes that I make, and Mukai Krishnamurthy, my co-advisor, who's a computer science professor at RPI, he talks about his mistakes. And I'll often say things like, great minds think alike. Not necessarily correctly, but alike. When a student comes up to me with a problem, with an answer, and it's the wrong answer, but it's the same wrong answer that I got the same time, the first time I did that problem. When I first started working with math circles, before I even dared to call it a math circle, I was afraid to admit that I couldn't do a lot of the problems, and I used to spend a lot of time preparing. I had a bunch of problems to which I had answers, but I didn't have explanations for how to get the answers, and I couldn't figure them out. And I used to spend hours cutting and pasting until I could find a set of problems that I could explain how to do. And then I decided it was really much better just to be honest and admit that I couldn't do any of those problems. So a lot of what I do is cheerlead, and I think that's a really important role there. And I have to say, just to put in one more autobiographical story, a lot of the reason that I felt the need to create Albany Area Math Circle was that when my daughter went for the first time to the Math Olympiad summer program, she discovered that sense of community and that belonging with kindred spirits that she'd never felt before. And I think that's an amazing thing, and it doesn't automatically happen. My understanding, when she went, she was lucky enough that when she went, Melanie Wood was on the staff. And Melanie is a cheerleader, and I'm sure that that probably made all the difference. A cheerleader can make all the difference in your life. You don't, it's not just math. There has to be something to inspire that confidence. My understanding from students, women students who have gone to MOP and instructors who went to MOP before Melanie was that it was not a positive culture. And I do sometimes see things even in my math circles that are not positive. And I try in terms of just thoughtless remarks people make, students make, that make other students feel bad. And so that's why I celebrate students like the Heart and Soul, the students who encourage other students. I think that's just absolutely critical, especially as your math circle scales up. You can't encourage everybody. But what you can do is empower students and I've seen transformations in students who were feeling bad about themselves once they had someone else to encourage. So that's my message, and I don't want to keep you too long because I realize lunchtime is coming. But one last thing is I also made business cards with our website address on them, which my students love handing out. I got a free offer, and it has our website on them. So that's another suggestion, again, for giving that sense of belonging. Once I gave them those business cards, and they hand them out at, like, you know, math contests and so on, or to younger students who express interest. It really makes them feel like agents of Math Circle. So thanks for listening.